This video is going to cover Unit 25, Section 7, angles formed inside and on a circle. Okay, so the first ones we're going to cover is angles inside a circle, which is like this one right here. All right, so if we've got, let's say we've got arc A, B, and then arc C, F. Okay, so it says on page 634 in the first blue box, an angle formed by two chords that intersect within a circle, which is what we have going here, is measured by 1/2 the sum of the two intercepted arcs. Here's our two intercepted arcs, arcs AB and arcs CF. So arc AB plus arc CF divided by 2 is equal to this angle 1 right there. So let's say that this arc is measured, let's say this one is 30 degrees and this one is 50 degrees. Now an arc can be measured in distance. So the distance from C to F, we've already done that kind of stuff. We have figured out the distance from C to F using the circumference and then the degrees divided by 360 multiplied by the circumference. We've done that. But an arc can also be measured by its degrees that it covers. Okay? So the distance and the degrees. So in this case, we would have 30 plus 50 divided by 2. So that would be 80 divided by 2. So this angle right here, angle 1, would equal 40 degrees. So that's a 40-degree angle right there. And of course, since this is an opposite angle to that, this one would also be 40 degrees. Okay? So now let's look at angles on a circle. So here we have angles inside of a circle. So the vertex of the angles is inside the circle. And this angle right here, we have the vertex is actually on the circle itself, right on the circumference. Okay? And let's go ahead and use the example in the book. So this arc is 103. So let's say that this is AB. So the angle here, so angle 3, for example, is equal to 103 divided by 2 is equal to angle 3. But I want to take a closer look at this equation right here, because it's very similar to this one right here. This one we have two arcs, add them together and divide by 2. Over here we sort of have the same situation. We've got this arc right here, which is arc AB, which is 103. And then we've got an arc over here too. Now the distance on this arc is 0. So it's kind of the same equation. We just have one of the arcs went all the way to 0. Because the vertex is actually on the line, but it's the same idea of equation. So 103 divided by 2 is 51.5. So angle 3 is 51.5 degrees. Ta-da! Now here's the situation down here. This is another angle on a circle because the vertex once again is on the circumference. So here we have a chord that meets the tangent line at the tangent point, and the tangent point right there is the vertex of the angle. Okay, so we're looking at page 635 near the top. an angle formed by a tangent and a chord at the tangent point, which is right there, I just mentioned that, is measured by half of its intersected arc. So this arc, we'll just call it 110. So 110. So this arc from here to here is 110. So 110 divided by 2 is equal to 55 degrees. So this angle right here is 55 degrees. All right? So now let's take a look at one of the examples. I already have it sort of set up right here. It is number 10 on page 637. So we're right here. And since I'm there, I might as well zoom in just a little bit so we can get a closer look. Now, let's see here. So we've got M right there, P right there, T, K. So those are our points. And then this angle right here is given as 56 degrees. So that's that angle right there. Now that is not going all the way to the circumference. It's just within this triangle right here. And then they give us, what else? They give us the distance, the arc from here all the way down here to T. So all the way around here as 170. So that is 170 degrees. Now, we need to find PM, arc PM. Okay, so that would be this arc right here. Okay, so let's say okay, so this angle, that arc, this is 170 right here. This is 56. Okay, all right, so here's how I'm going to find that. This is how I can find it. If I knew the arc in degrees from P to T, I could subtract that from 170 to get this arc right here. Well, how can I find this arc right here? So this is an arc with a vertex on the circle. So I would take this arc length right here and divide it by 2 to get the angle. Well, I already have the angle. Okay? So I need to go back the other way and multiply 56 times 2 to get this arc right here. Because it is this arc right here divided by 2 will get me the angle. But now I have the angle and I need to find the arc, so it's multiplied by 2. And 56 times 2 is 100, 112. So this arc length from here to here is 112. So the arc length from M to P is 170 minus 112, which is 58. So arc MP is equal to 58 degrees. Now we need to find KT. So arc KT. KT. So from here to here. What do I think here? Okay, right here. This angle right here is 90. All right? Because it's given to us. Right there. 90 degrees. So this arc, we already know this angle, not the arc, sorry. This angle right here is 56. So this angle right here must be the rest of that 90. So 90 minus 56 is 34. So this angle right here is 34 degrees. Okay, so that's this angle right there. So that means that this arc is twice that angle, because this angle is half the arc. So the arc must be twice the angle. So KT is equal to 68 degrees. Does that make sense? Well, yeah, everybody who got that, raise their hand and scratch their nose or something. I don't know. I'm so used to asking if it makes sense. There's nobody there to respond. Maybe someday. Well, I can't do live streams. I wanted to do live streams, but YouTube won't let me do it because I think I need 500 subscribers, if I'm not mistaken. It's a lot more than I have. I don't even know if I have any, to tell you the truth, and that doesn't matter. But I wanted to do live streams, so I can't do live streams because I don't have enough subscribers. So I'll have to figure something out. But I hope this is kind of working out a little bit the way it's working now. But anyway, so I'm just using, for both of these, I just simply used the opposite of the equation. Now remember, in algebra, you can do that kind of stuff. So when you can solve for one, you can turn it around and solve it the other way.